Good morning and welcome to another episode of Making Torque. Today we've got an interesting occurrence on our hands. We have a tool in, but it's not a torque up tool. It's one of our competitors' tools. As you've seen in previous episodes, we trade in our competitors' tools and then dispose of them. But what you may not know is we also calibrate our competitors' tools. But when we do that, we go through a check out all the aspects mechanically, hydraulically, all over the tool, front to back, just as we do our tools when we bring them in for repair or calibration. But we've got a unique situation here with a power cylinder from a competitor's tool. I'm going to show you why, and we talk about the reason why, but now we're going to show you the reason why this tool is leaking. So come over here on the bench, and we're going to show you this competitor's power cylinder, just the power cylinder side of this tool, and you're going to learn why we do what we do the way we do it, which is how we machine our products and what we use as far as our materials compared to how our competitors do it. So let's take a look. If you take a look at the cylinder here, this is the power cylinder. This is where the piston is inside of here, all the pressure. We have the same thing with our tool. It's a power cylinder. Then we have a link or a head. On this tool here, you have the power cylinder, the piston is in the back area here, and the piston moves forward and backward. Again, an advance and a retract, hose going into it, high pressure in, pushing the piston forward, and then low pressure pushing the piston back to reset it. This particular tool is cast, which is something that we do not do. We don't cast our tools. All of our tools are machined from billet, all AQ quality billet. When you cast, there could be the chance of porosity in the casting. In essence, in simple terms, there could be bubbles inside of the casting. The real way to find out that you don't have these bubbles is to x-ray it. So that means that every cylinder that's cast, I would assume then they would machine it, and then you'd x-ray it to make sure that none of the porting and things inside of it are coming through small bubbles with inside the housing. And what can happen when you have porosity inside of the tool? Obviously, if something was to crack or break in the back of the tool, you'd find leaking from it. But should you ever just find leaking coming straight out of the side of the housing or right in an area here as such, and that shows that the tool does have porosity. We're going to turn this tool on, we're going to turn the pump on and put pressure into it. In fact, I don't think we're going to have to put that much pressure into it, and we're going to see something occur right here. And we're going to try to zoom you in a little bit. So it's going to get a little noisy. We're going to turn the pump on, and then we're going to show you why we machine our tools out of billet instead of cast them. So let's turn the pump on. And if you come up close here and you look, you'll see there's oil just coming straight out of the housing. We shut the pump off. It's right in this throat area here. So if we turn it back on again, coming right out of the housing itself. Continuing to come. Let's turn that pump off again. So again, this is not a place that you'd see typical oil leaks. There's hoses going into the tool. There's threaded nipples going in, male, female. So if those are loose, if there's a crack in the fitting, you'd see oil coming from here. There's a piston moving forward in the front of the tool here with a gland. There's seals and O-rings inside of here. You'd see oil leaking here. But you would never really just see oil leaking in the throat of the tool here. If you want to turn that on again, there's the oil continuing to come out. The oil. We'll shoot some close-ups of this so you can really see that right from an area of the tool that's not stressed, right from an area of the tool where there are no O-rings, it's leaking. And again, the reason for that is porosity. This tool is cast. Our tools are not cast. So when you take a look at considering a hydraulic torque wrench from anybody out there, make sure that the housings, this is where we put 10,000 psi of pressure. It's 10,000 that goes behind that piston, moves it forward and backward. The last thing in the world that you want is, and we're not even putting a lot of high pressure into this right now, we're just moving the piston forward and backward, low pressure. What would happen here is a high pressure spray, which could come out and inject into your hand. So When considering a hydraulic wrench, go for the ones that are machined out of billet, like a torque up tool is. Our TU, TX, all of our tools are machined straight from aircraft quality aluminum, aircraft quality alloy steels, and never cast. Take care.